Hey there, today we are going to continue practicing with two variable equations. It can be very confusing to learn two variable equations for the first couple of days or practice sessions, but it does get easier. I wanted to remind you of the types of two variable equations. In the pink box, you have the one-step two variable equations. Those will have one relationship. And in the yellow box, you have the two-step two variable equations. Those will have two relationships. Two variable equations also always have two quantities because there's some variable that's going to be the x and some variable that's going to be the y. Off to the side, I have over here some examples of independent variables and dependent variables. Independent variable is often time, weeks, days, months, years, hours, minutes, anything like that is usually but not always an independent variable. Also, x goes with independent variables. Dependent variable is often money. There's lots of other things it could be, but if money's in the problem, it's usually dependent. Also, dependent variable goes with y. So let's practice some more of these. I'm going to have you guys start by going through here. So do quantities, relationships, let x equals, let y equals, independent variable, and dependent variable. Pause the video when you're done with all of that, unpause the video, and we'll go over it. All right, so let's see what we can come up with. The quantities I see would be cookies. Oh, not cookies. I don't know why I said cookies. I would think it'd be money and weeks. So I keep seeing the money sign over and over. And the question is, how much money does he have after X weeks? So I could see both of those variables in that question. One of those quantities is going to be our independent variable and X. One of those quantities is going to be our dependent variable and Y. Relationships. Let's see. I see add. He's going to add $10 each week, and I see each. So since I have two relationships, my equation type will probably be like one in the yellow box, the two-step, two variable equations. All right, so now I know that whatever I put for let x, I also have to put for independent variable. Whatever I put for let y, I also have to put for dependent variable. All right, let's see. I have money in weeks. Money is a very common example of a dependent variable, and weeks is time, which is a very common example of an independent variable. Independent variable and x go together. So I'm going to fill out weeks for both of those. Money goes with dependent variable and y. So I'm going to fill out money for both of those. So now I'm done with that section. Now it says the equation to represent the situation is 25 plus 10x equals y. We didn't even have to make our own equation, so that's nice. So this is the equation we're going to be using. It says if y equals 65, what is the value of x? So what they want us to do is rewrite this equation, but instead of y, they want us to write 65 in that spot. Since we defined y to be money, up here we said let y be money, I know that this is asking about $65. We want to know how many weeks have passed for Caleb to earn $65. Pause the video, see if you can solve for x. All right, hopefully you've tried solving for x. In a two-variable equation, we can only solve it once we know what one of the variables equals. So we know that y is equal to 65. This allows us to solve for x. This is a two-step equation, so I know I have to add or subtract first, then I have to multiply or divide. I need to take away 25 from both sides, and I get 10x equals 40. This is multiplication now, so I have to divide both sides, and I get x equals 4. Let's look at what the unit is for x. up here it says let x be weeks. So I'm going to write 4 weeks. All right, so I'm going to have you guys pause the video and try up to this. You're not going to do the equation stuff yet. Unpause the video when you're ready to go over it. All right, hopefully you're ready to go over it. So let's break down this equation. The quantities I'm seeing would be dollars and miles. Those are my 2 units. So I know there's going to be an x and a y in this equation because there's 2 quantities. Relationships, let's see. I see addition and I see per. So it's a 2-step one. Addition and per. So I have to decide if my money goes with X and independent, or if money goes with Y and dependent. Well, money is a very common example for a dependent variable. So I'm going to put that in both of those spots. Miles is, it's not necessarily a common independent variable, but it's the only choice left. So because they gave us the clue about miles, it was easier to figure out the X and the independent variable. Those always have to match. All right, so if you look at the equation types in the green cloud, and you might have to take a screenshot so you could see it lower down, see if you can come up with the equation to represent the situation. You're going to start with y equals and see if you can come up with the rest of it. Pause the video for some think time, then unpause when you're ready. All right, hopefully you're ready. So it says a $6 flat fee in addition to, so 6 plus, $1 per mile. It makes you think you want to write 1x, but remember we never write the 1 as a coefficient, so just 6 plus x would be the correct equation. Y equals 6 plus x. This is like, it's kind of a combination between these 2 equation types. It is technically a 2-step, but the coefficient happened to be 1, and so we got rid of the 1, and then that made it into a 1-step equation. So we lucked into having less work to do. All right, pause the video, see if you can solve the follow-up question. Unpause when you're ready to go over it. All right, let's take a look. So the first thing we have to do is figure out which variable we're going to substitute the 3.5 in to. So it says 3.5 miles. I meant the highlighter. 3.5 miles. So which of my variables goes with miles? It's x. X goes with miles. That means I have to substitute 3.5 in for x. So my equation now becomes y equals 6 plus 3.5. There's no algebra to do. All of the numbers are on the same side, so it's just order of operations. I like solving for y better because you don't have to do algebra, you just do order of operations. 6 plus 3.5 is 9.5. And what should my unit for y be? Y is money. So the answer would be $9.50. Don't forget that 0 at the end. Let's keep going. All right, so let's see. Why don't you guys try to do this much? You'll go right to the equation, but you won't do the 2 follow-up questions yet. Pause the video, come back when you're done through the equation. All right, hopefully you're ready to go over this. So the quantities I'm seeing would be money, and you could either say pounds or you could say apples. And I know that from looking at the end of the question, it says, what is the total cost for X pounds of apples? You could have also written pounds of apples. Strawberries, although it's a unit, is not a mystery. She bought $10 of strawberries. It's not a mystery how many strawberries she got. That's solved for already. The apples are the mystery, as well as the total cost. All right, so that's my quantities. Relationships, I see per, oops, I wanted to highlight it first. That's why I was on the highlighter. I see per, and I see total. Per and total. Since I have two relationships, I know that this is going to be a two-step equation. And I might go grab my bubble, my cloud, so that way we can look at that. Put it at the bottom of the page. So I know that my equation is going to be one from the yellow box because I found two relationships. So now I have to decide what quantity goes with what variable. One of them is going to be with X and independent. One of them is going to be with Y and dependent. So let's see. Well, I see money. Money is a dependent variable, and it goes with Y. So that's going to be money. And then that leaves pounds or apples or both or pounds of apples to be with the independent variable. And that makes sense. The total cost depends on how many apples I've bought. All right, now the equation. Let's see, it always starts with Y equals. What do I think it's going to be? She already has $10 of strawberries. And I want to add to that the total cost of the apples. So plus 1.5x. That's saying $1.50 times the amount of pounds of apples that she's getting. I could have also put it in the other order, 1.5x plus 10. So this is like two-step equation type number 1. All right, so now we're going to try the follow-up questions. Try the first one, pause the video, unpause when you're ready to go over it. All right, hopefully you are ready to go over it now. I have my equation, Y equals 10 plus 1.5x, or you could use the other order of it. And it's saying that she bought 3.75 pounds. Well, which variable goes with pounds? X. X is pounds. That means I need to replace X with 3.75. So Y equals 10 plus 1.5 times 3.75. Since the variable is already isolated, this means I do not have to use algebra to solve it. I can use the order of operations. My first order of business is going to be to do multiplication. For this, I'm going to have to multiply 1.5 times 3.75. You could multiply this however you feel comfortable, but remember when you multiply decimals, you take out the decimals and you add swoops back at the end. So I'm going to do 375 times 15, and I hope I don't embarrass myself and make a mistake in front of you guys, but it's always possible. So let's see. So 5 times 5 is 25, 5 times 7 is 35, plus 2 is 37, 5 times 3 is 15, plus 3 is 18. Put a 0 placeholder. 1 times 5, 1 times 7, 1 times 3. Let's see, so I have 5, 2, carry the 1, that's 16, and that's 5. Hoping this is correct and I'm not embarrassing myself. I have 1, 2, 3 swoops to do. 1, 2, 3. I'm making my swoops nice and big so I can see it. And I got 10 plus 5.625. Now I just need to add 10 to that. And I got 15.625. So the question is, what is the total cost? Or I know that this is what Y equals, and Y equals money. So either way, I'm going to have a dollar sign as my unit. 15.625. But we know that money can only be written with 2 decimal points. So I have to decide if I want that 2 to stay the same or for it to bump up 1. I do want it to bump up 1. So 15.63 would be her total cost. All right, pause the video, solve this last follow-up question, unpause when you're ready to go over it. All right, hopefully you're ready to go over it. Now, this is a tricky question because there's two different ways you can solve it. If she has $35, can she afford to buy 18 pounds of apples? You have two choices. You can solve for how many pounds she can get for $35, or you can solve for how much money 18 pounds of apples will cost. Your choice. I think, I could show you both. So either way, you start with your equation, y equals 10 plus 1.5x. First thing I know is that she has $35. Dollars goes with y. So I have to put the 35 here. 35 equals 10 plus 1.5x. When I solve that, I'm going to subtract 10 from both sides. I get 25 equals 1.5x. Divide both sides by 1.5. And I'm going to have to do some scratch work. 25 divided by 1.5. Since there's a decimal on the outside, I need to swoop over one. So it's going to be 250 divided by 15. 15 goes into 25 once. I get 10, drop down the 0, and get 100. 15 goes into 100. I actually don't know, so I'm going to have to make a little chart in my head or off to the side. Let's see, 15 goes into 100, I think, 6 times. And 15 times 6 is 90, so yeah, it goes in that many times. And I don't even need to really keep solving. I have enough information to see that she can buy only 16 pounds of apples in some decimal place. It would keep going, but 16 in some decimal place. So she can buy 16 pounds, which is not 18 pounds. So no. That's one way of doing it. I'm going to put this off to the side. The other way of doing it is if I start with my equation, and this time I put 18 pounds into the equation. So that's going to be y equals 10 plus 1.5 times 18. This is because 18 is pounds and pounds goes with x. Since the y is already isolated, I'm just going to use order of operations. 1.5 times 18 is 27. And that equals 37. It would cost $37 to get that many apples. So no, again, you wouldn't show both of these. You would just show one of these. All right, there is this page next. I'm